Yeah, participants, sorry for the interruption. We will just resume back.
Hello.
Yes, Kevin, you're audible.
Can I start?
Yeah, you can just start.
Okay, fine. Can anyone comment about this two figures, the left and right side?
First one is perfect positive relationship.
Yes.
Second one is negative correlation.
Yes, it's perfect.
Negative.
Positive and negative correlation. Very good. Thank you. Then, yes, perfect positive and negative. So see these two figures. These are nothing but scatter plots that we get out of softwares. So how could you relate these two figures? Anything you get out of this figure, the left figure? I think you can see a trend going from the. Yes, it is.
Strong positive.
Yeah, it can be a strong positive kind of relationship. Good. Then in the right side, there is a trend going towards the right. Yeah, it is not a strong negative, maybe weak to moderate kind of negative correlation. Okay, thank you. See these two figures that is given on the left side and the right side. Anything you could get out of this figure? Anything you can see? There is a relationship between age and the survival time in days. Both are quantitative variables, that is numerical variables. This is plotted in the graph. Can you infer anything out of this figure? Okay, it is neither a positive trend or negative trend. It's somewhere in between. We could not see any trend going on in this dots or figures. So it is a non-linear kind of or no linear relationship kind of figure. Whereas this side, the right side, it is also more or less a zero kind of relationship. It is neither positive or negative. This is a kind of the left side is a no linear relationship, whereas the right side is a non-linear. To be specific, it is a curvilinear kind of relationship. Okay. So this entire spectrum going on from the entire ranges from -1 to +1. -1 being perfect negative, +1 being perfect positive, 0 meaning it is a no correlation, and in between it is a stronger to moderate and weaker kind of relationship. The figures will be like this. Okay. Now use Pearson's correlation with a kind of with a pinch of salt, or you can say it. You can use it this in very sensitive way, because now see this figure. This figure in the x-axis we are given the fertilizer amount. In the y-axis we have given the plant growth rate. So as you keep on increasing the fertilizer amount, we could see the similar rate increase in the plant's growth rate. But once you reach some peak here, after some time, after this also, if you increase this fertilizer amount, what will happen? The plant growth rate will be, it will be toxic to the plant, so that the plant growth rate will be starting to decline in that manner. So this is an example of which kind of relationship we see in the last image. Curvilinear or non-linear kind of relationship. Yes. So whenever you see this kind of relationship, what happens? We could not get a conclusive picture from this Pearson's correlation. So only this Pearson's correlation is only applicable for the linear association. It is not for the non-linear kind of association given at any given instance. Now see this correlation coefficient. We have drawn the correlation line, and the R value is being given as 0.54. But look for this dot that is sitting out away from this normal picture. So it is termed as outlier. I think you have heard this in the previous lectures. This being termed as outlier. Now, what we will see, what if this outlier is being removed from this data analysis. So see this, now we have removed this outlier from the data. Now the R level has significantly improved from being moderately positive correlation to considerably strong kind of positive correlation. So that is why in the early lectures that Anand sir and Vijay sir and even Josephine ma'am had said about any outliers in the data is very annoying for the data analysis. So preferably if there is any gross outliers, we tend to remove it, or we use some other statistical technique to include this outlier in the statistical analysis. Preferably we remove this outliers. Hence, in this second graph that is being shown here, they have removed this outlier and tested this correlation. You can see nearly 20 points or 17 to 20 points the correlation has improved. So next question is, so what would you infer from this picture? Any guess?
Sir, can you change your interface? Because we cannot see your presentation as much as on the earliest workspaces.
Okay, I will just let you. So now it's clear?
Yes.
Okay, thank you for pointing out. So now this figure, what would you gain? What would you interpret in the first instance? Which trend is there? Positive or negative trend? And see now?
Positive trend.
Yes, it's a positive trend going on towards the right side. So it is a moderately positive. If we interpret this image and if we conclude R is equal to 0.57 and if it is moderately positive correlation, then we have did a major mistake, because there is something going on in the background. Could see now, this is the image that we got right now. Then if you could see in the subgroups, that is for females, there is a negative correlation. And for the males separately, you can see that there is a negative correlation going on. So if we could contour this image and if we report it as R is equal to plus 0.57, we had did a gross mistake, because this data group has some subgroups. These subgroups analysis is very essential whenever we interpret the findings. So this Pearson's correlation is not sensitive to, it's sensitive, but we should remember this in the data analysis or reporting. There is some subgroups on this cluster of points leading to an inflated correlation coefficient. It is an overall correlation, but individually in the subgroups it is a negative correlation. So just a brief summary about this Pearson's product common correlation. Assumptions are normal distribution. Both the variables are continuous and normally distributed random variables, and there are no relevant outliers. I think for any statistical test, we see these assumptions. And this product correlation is only for the continuous variable that is linear in nature, and this ranges from +1 to -1. And always remember, any correlation findings is not equal to causation. It means if we correlate age and the urea levels, age and urea levels are correlated, doesn't mean that increased age is the only cause for the increase in the urea levels. That is the only thing we need to remember whenever we interpret the findings. Now, we saw Pearson's correlation is not for non-normal distribution. It is not for the ordinal data. It is not for the non-linear kind of relationship, and it is not sensitive. It is sensitive to outliers, so that outliers cannot be used. So what is the solution at this point of time? Do you have any solutions? If at all we have this kind of data in our data analysis, should go for the alternative method. What is the alternative method?
Spearman.
Yes, it's a Spearman's. Good. So in Spearman's, this is same kind of two quantitative variables, but the relationship may be non-linear. Also, what we do in Spearman's is we convert this absolute values, that numerical values, into some kind of ranks. For example, if we have some data such as 12, 22, 32, 42, 52, something like this, what we will do, we will rank this in the higher to lower range, and we will give number 1, 2, 3, 4, 5. That is nothing but are giving the ranks to the each values. So by this step, we convert this absolute values into ranks. So if once we done this step, then we can easily use this the same correlation method, so that what we get out of this is a rho or pair correlation coefficient calculated by Spearman, that is RS. So for example, in this data, what we have, for assuming this x-axis is the age and this y-axis is the number of free radicals generated. Free radicals are nothing but due to aging process, the body generates some kind of chemicals in the body, which is causing the aging. So maybe up to 30 years, this free radical generation is very less. After 30 to 40 years, this free radicals will be very more. That's why we get a relationship like this. So after some 30 to 40 years, there is a steep increase in the number of free radicals. So for this data, if we calculated R, we got correlation that is positive, but it is a moderate to strong. But for the same data, if we calculated the Pearson's correlation, the data yields a very strong or a perfect kind of correlation between the age and the free radical generation. That is the value of Spearman's correlation if at all we have a curvilinear kind of relationship. Also, see here in this figure, in the right side, figure number B, if you can see, using a normal Pearson's correlation, we could get the data out as 0.84 because we have an outlier here. Either we can remove this outlier and calculate the Pearson's, or include this outlier and calculate Spearman. The Spearman will give you a better yield, that is 0.99, which is near perfect kind of relationship. So this figure, right side D figure, it's a normal figure. It is evenly scattered. There is no assets, there is no outliers. Hence, both the Spearman's and the Pearson's yielded near normal result in the output. So this is how we can use either Pearson's or Spearman's in the data analysis. So now we could establish the relationship S, there exists a relationship, and we also calculated the strength of relationship either by using Pearson's or Spearman's. Now, my question is, if we know the X, that is the age of the person, can we calculate, or is it possible to estimate the urea level of the patient? If yes, then how could you establish this relationship? Any idea?
Regression.
Yes. So that brings to the topic of regression. By regression, we can either predict and estimate the value of dependent variable from the independent variable. So this is the only table that you need to take home today. It gives you, and of course, because everything is available in the software, you can. But only thing you need to know is which technique you need to employ in the software before doing the regression. So in this, we have given into two tables, that is dependent and independent. If the independent variable contains a quantitative and the dependent is also quantitative, we can use linear kind of regression, that is linear regression. But in both the independent and the dependent, we have a single variable. So, for example, we can take it as a age as the exposure variable, that is independent variable, and blood sugar value as the dependent variable. So if this is the case, then we can use the simple linear regression. It is a linear regression being single variable in both the cases, and it is a simple in nature. So if it is the same case, we are going to estimate the blood sugar value, that is the outcome variable, but we are going to take two independent variables, that is either that is age and the body mass index, that is BMI. So we are having now more than one predictor variable or the exposure variable. So at this point of time, we are having multiple variables. So we are using multiple the same linear regression. But now comes the question: what if there is if the dependent variable or the outcome variable is a qualitative variable or a categorical variable? It can be either two outcomes or more than two outcomes. For example, if you are going to doing a study to find out the depression in the patients, depression yes or no is the two outcome scenario. If that is the case, then you can use binary logistic. If it is a qualitative, then it is logistic regression in both the cases. But if it is two outcomes, you are using binary regression. Binary meaning two. But if it is more than two outcomes, for example, for the same depression, let us leave depression. We can take any other example like preference of drinks in the patients or something like that. We can, the preference of drinks may be tea, coffee, or soft drinks, or simple water. Now we are having more than two outcomes, but the outcomes are all categorical in nature, qualitative nature. Then the case will be multi-nominal logistic regression. Qualitative meaning logistic regression. If it is two outcomes, then binary, more than two outcomes, multi-nominal. Then comes the next scenario. For the same depression that we have calculated in the two outcome scenario, now we are going to order that or rank that using some techniques, maybe mild, moderate, severe, or depression type 1, type 2, type 3. So any example, if you're using this as an ordinal kind of output in the variable or in the dependent variable, then we are using ordinal regression. Next comes the final kind of regression, that is known as Poisson regression. In this, the outcome is a numerical, it is a number, it is nothing but a number or a numerical data or quantitative data, but here the number is not the continuous, the routine continuous type. Here we are going to have the counts. For example, number of readmissions, number of falls, or the number of maybe events, any adverse events in the trials, anything you can take. If it is a count, and then the distribution tends to be towards the either right side or left side. It is, we already discussed, it is not in the bell-shaped curve. Then it is the Poisson regression that we need to undertake in the data analysis. So remember this table, it's very, very useful for you during the employment of this techniques during the data analysis. So coefficient of determination is nothing but, now we said age and urea are related. Now we are going to see how much variability in the urea is contributed by the age per se. Age itself, in other words, how much change in age is having an influence on the how much change in the urea. That is known as coefficient of determination. We calculate that by just squaring the R value. In our example, we have got the R value as 0.61. If you square this value, you will get this 0.38. It means, this simply means explained variation divided by total variation. In other words, 38% of the variation in the urea levels can be explained by the age of the patient. It means only the urea level is changing from age to age, but only the 38% is being explained by the age. The remaining 62% is not explained by the age itself. It may be due to other factors, or it can be due to random error that we don't know, but it is not explained by the age. That is the only inference out of this figure, that is R square value. So next thing is simple linear regression. This regression is nothing but developing a model based on various steps, and the ultimate output of this steps is the regression line or the best fit line, which gives you this regression equation, that is y is equal to a plus bx. So let us dissect this equation so that you will understand this better. This equation is going to give you the best fit line. This is the best fit line that is going on from the left to right side. This is not as similar to the correlation line that we saw earlier. This is a line of best fit or regression line. This line will be extending towards the y-axis. So this line will be meeting at some point in the y-axis. That point is known as, this is being taken as baseline or intercept line on the y-axis. That value is being noted down. Then in the B is nothing but a slope, which gives you delta y or divided by delta x. It's nothing but how much change in y happens for how much change in the x. It's nothing but a rate of change. For example, if x changes from this point to this point, for this instance, there is how much change in the. So we divided this delta y divided by delta x, which gives you the rate of change. This is nothing but the value of b. So hence we know already if we know x, if we know the x, and if we can calculate these two figures A and B will be given by the software. Once you know this, then you can calculate the y. For our data, we have calculated this regression line. We could get the equation as 0.726 plus 0.017 into x. So if we could substitute any age, for example, if you want to know for at the age of 50, what will be the urea level in the patients? We can do this by 0.72 plus 0.017 into the value of x that we had taken as a 50. If we do this and substitute, we will get the urea level will be 1.57. So similarly, you can calculate for any age, what will be the data for corresponding urea levels. So with this, I summarize today's understanding about the two quantitative variables. Just remember this a single slide. If you are given any two quantitative variables and if you want to find the relationship, and if you want to just know whether there is any relationship, or if you want to estimate the strength of the relationship, use only correlation. So correlation is nothing but an assessment technique. It is not an estimate. It is nothing but is simply an assessment technique to find out the complexities between the relationship. Next, if you want to do more than this, I want to estimate the y outcome variable based on the x or independent variable, then use regression, which is a prediction and estimation technique. Don't confuse between correlation and regression. Both are entirely different. In the correlation, we are going to just assess and estimate the relationship. And for the given two variables, whether there is any relationship or what is the strength of the relationship. But we cannot do any prediction or estimation in the correlation. But whereas in the regression, we can estimate if we are given any particular exposure variable, we can easily estimate the output variable or outcome variable. So these are the references. Any queries, I would be happy to help you. Anybody has any queries regarding basic approach to regression and correlation?
Sir, in the table that you showed, so you had that the outcome variables when it is qualitative, then which ones we will use regression ka the table. So why would we use regression for when the outcome variables are qualitative? Because we need to use chi-square only, no, in that case.
No. Chi-square is nothing but chi-square is not just gives you the measure of association. Either it is how is two things. Now we are going beyond this. We are going to predict. Chi-square cannot give you if I am giving you some variable, for example, age. For example, for 50 years of age, what will be my blood sugar? For 50 years of age, what will be my urea level? Any variable per se. So you cannot do any kind of estimation or prediction out of chi-square. This is entirely a different segment where we tend to correlate and we tend to predict the outcome as well as estimate the outcome variables. So both are different techniques in the in the basic nature of the tests.
So that
Sir,
means,
one doubt.
so sir, that means that in that table, that means that the outcome variable is ordinal in nature, is it? In that regression table that you.
Yes, if it is an ordinal in nature outcome variable, then you are going to use the ordinal regression. This is a separate kind of a same technique, but it is an ordinal regression.
Okay.
Yes.
So one doubt.
Sorry.
Told the correlation is not a causal correlation, not equal to causal association. So if you have to calculate the causal association, how to do that, sir?
So causation is not only if you could remember, any association we establish during correlation or regression is not equal to causation, because we are just doing the statistical technique to say how close these two variables are. But the causation has its own criteria. That is, Hill's criteria for causation, right? 9 criteria: biological plausibility, the exposure after the outcome. So all this criteria, you can refer to the Hill's criteria. So that says we could not establish these criteria with this. This is merely a statistical test. So statistical test just give you an idea whether two variables are related or correlated. It will never give you you can never estimate the causation only with the help of statistical tests. We need to have the clinical acumen and biological possibility kind of approach and all those criteria given in the Hills criteria. So
Yeah.
that's why I said
Thank you.
causation or is different from the correlation or association. Yes,
Thank you, sir.
thank you.
Sir, if, for example, if you're considering doing any death audit and to know the epidemiology of that particular disease causing the death, can we apply both regression models like the logistic and that linear regression if the variables are sort of quantitative and qualitative both?
Yeah, depends upon your objective, right? For example, I can measure my study is based on, let us assume, diabetes. Okay, so I can either measure the blood sugar level in the diabetics, or I can classify the blood sugar level into pre-diabetes, diabetes, and the next level, whatever the classification is. So if I classify them, then it becomes an categorical variable. If I don't classify them, it becomes a kind of continuous variable, quantitative variable. So in that case, if it's a continuous variable, then we can use the linear regression. If I classify them, then you can use the this logistic regression. If it is two outcomes, either diabetes yes or no, then it is binary logistic. If it is more than two outcomes, that is mild diabetes or pre-diabetes, severe diabetes, then we can use this as a multinomial regression.
Okay, thank you, sir.
Yeah. So hope this is I already said you this is not an entire series about entire thing about regression and correlation. I've given you just insights about this thing. You are free to explore more about these techniques, and if you are able to if you want to come back anytime, you can contact our coordinator so that we can have an advanced course in correlation regression at some point of time, some other point of time. Thank you.
So one
Yes,
second. sir.
yes.
Sir, if we see on the SPSS, if we do analyze, correlate, there are three options: bivariate, partial, and distances.
Okay, in software, in the hands-on,
Yes, sir.
what are the three types?
If we choose on to analyze, correlate, there are
Okay.
three options: bivariate, partial, and distances.
Okay, maybe I will ask Anand sir to give you the insights about this three types and when to use this three kind of approaches.
Yeah, if we can use this knowledge to
Yeah.
application.
Sure. Okay.
Thank you.
So I hand over my session to Dr. Vijay Karthikeyan. Thank you.
Thank you, Dr. Kavin Kumar. Am I audible?
Yes, sir. You're audible, sir.
Yeah.
So there is
So-
one query in the previous session, that is during the correlation, they have given two quantitative variables and partial, and there is some options in the SPSS software, I think. So I'm not very sound in this three categories. Please give some insights about this. Thank you.
Yeah, I will touch upon those.
Thank you, sir.
Thank you, sir. So Yes, am I audible?
Yes, sir.
Yeah. Is my data sheet visible?
Yes, sir.
Okay then. Okay. Yeah. Sorry for the delay. Okay. So I will just tell you what all we are going to see and what we are not going to see. See, we are not going to go into the specifics of certain advanced things. For example, we will be touching about chi-square t-test, independent sample t-test, and the alternative non-parametric test. And also we will touch upon Spearman correlation, Pearson correlation, and we will be going into the regression, linear and logistic. We are not going into the details. For example, we are not touching about post-hoc analysis of ANOVA. We are not touching about the MANOVA, ANCOVA, and all those. And we are not touching upon bootstrapping. And also we are not touching upon the interaction models in the regression. For example, we have something called block regression and hierarchical regression. Okay, so first, inferential statistics, we will go from the basics. Okay, I hope you all have an idea about what test to use when. Okay, so let us go step by step. I want you people to interact with me. Okay, so first, in this nicotine sheet, our dependent variable is this one. This is our dependent variable. Okay, so those who have low to moderate and high dependence, and those who have low dependence or no dependence. So this is going to be a dependent variable. Okay, now I want to find the association between nicotine dependence and occupation. Okay, and occupation. So occupation has three categories. One is the unemployed, other one is the skilled workers, and other one is the professional. I want to find the association between occupation and nicotine dependence. What statistical test should I use?
Monday, Anova.
Can't get you, ma? Now we are going to see the association between nicotine dependence and occupation. Both are qualitative variables. Okay, what statistical test should I use?
I-square.
Exactly. So in SPS, I'm going to show you now how to use chi-square. Okay, so you are going to go to analyze. You are going to go into descriptors. You are going to go into crosstabs. Okay, crosstabs, and here you are going to select the occupation, and you are going to put it into the rows. All the independent variables will go into the rows, and the dependent variable will go into the column. Where is the dependent variable? I have it over here. Okay, and in statistics, I'm going to go and I'm going to give chi-square. Okay, I'm going to give chi-square and I'm going to click risk over here and I'm going to click continue. So this is the statistics for the crosstabs. So I need the chi-square, I need the odds ratio. So I'm going to give continue. And in the cells, I'm going to give row percentage and column percentage. And I'm going to give continue over here. Okay, so if I give okay, so this is going to be the output. This is going to be the output. Okay, so I am not going to go into the detailed explanation of this table we have over here. What you want to see is what is the value of the chi-square. Okay, so this Pearson chi-square value 12.37 is the chi-square value. And here you have something called asymptotic significance, which is the p-value. So p-value is less than 0.05 and this is the value of the chi-square. There is a statistical significant association between occupation and nicotine dependence. This is what you are going to see over here. Okay, so here if you see, you have the row percentage and the column percentage. So this is the row percentage, this is the column percentage. Ideally, while writing your result as a table, you have to use the row percentage. Okay. So this is a preliminary bivariate analysis. Bivariate, variate, variable, by two. Association between two variables which are qualitative. Okay, which are qualitative. We use chi-square. We go into analyze. We go into crosstabs. We put the independent variable over here. We put the dependent variable over here and go to statistics. Click on chi-square. Click on risk and give continue and give OK. We get the chi-square value. Risk estimate is nothing but the odds ratio. Risk estimate is nothing but the odds ratio, which is not calculated because odds ratio can be calculated only for 2 by 2 tables. Okay, 2 by 2 tables. For example, instead of occupation, I take the marital status. Okay, married, unmarried, it carries only two categories. If I give OK over here, then here, if you see, we have the chi-square value, we have the p-value, okay, and we have the odds ratio table over here. So odds ratio for marital status, this is the odds ratio, 0.261, and here it is 0.13 to 0.51. Okay, so this is the odds ratio. So this means that odds ratio is protective. It is less than 1. It is less than 1. Okay, so it is protective. So you have to say that here marital status 1, 2. So the category 1 belongs to unmarried, category 2 belongs to married. I'll just confirm once. Okay, so 1 is unmarried and 2 is married. So here, if you see over here, 1 is unmarried, 2 is married. So 26%. So those who are unmarried are 26% less likely. Okay, 26% less likely to be nicotine dependent. Okay, so if, as you would have seen in the previous sessions, odds ratio should not include 1. Okay, should not include 1. Here it is 0.13 to 0.51. So it is a protective factor. So it is a protective factor. If it is above 1, you will say it is 1.2 times increased odds of having nicotine dependence. Those who are unmarried have a 1.21. If the value is 1.21, you will say that it is 1.21 increased times of having nicotine dependence. So here you are going to say 26% less likely. So unmarried, if it is above 1, it is increased odds. If it is below 1, it becomes less likely. So 26% less likely to be nicotine dependent when compared with married people. Okay, so this is the bivariate analysis between two qualitative variables. Okay, clear. So this is the chi-square test. Any doubts in chi-square?
Sir, 26% protective na the value 0.261 வரதுனால 26 ன்னு சொல்றோமா சார்?
ஒரு நிமிஷமா. எங்க கேளுங்கம்மா என்னம்மா?
Percentage of protective between the marriage status and nicotine dependence சொல்றது இந்த 0.261ங்கிறதுனால 26% ன்னு சொல்றோமா சார்?
ஆமா exactly. See, since it is less than 1, you are saying 0.26 or you are saying 26% less likely. There's other way of putting this also. 100 minus 26. How much? We get something around 874. So you can say 70% more likely also. Okay. For example, the category 2 is married. Those who are married are 74% more likely to be nicotine dependent. So either way you can go. So to avoid confusion, I am telling you to follow this way itself. Okay. If it is 1.2, you say 1.2 increased odds. If it is less than 1 and you find something in the 0.26 or 0.36, you will say 26% less likely or 36% less likely to be nicotine dependent. Okay. So what you have to understand is whatever category you have above and whatever category you have over here are at the higher risk. For example, here we have the unmarried over here. Here we have the nicotine high dependence over here. So this and this, both things, the basic 2x2 contingency table, even when you see in case control, cohort, or cross-sectional, wherever if you see the construction of a table, this relationship will be there. Whatever you have over here will be the highest risk. Whatever you have over here will be the highest risk. Okay, likewise, unmarried has the highest risk. 2 is married. Okay, so we have put it above. We have put it above. So 1 க்கு கீழ இருந்தாலே you have to interpret as less likely or more likely. If it is above 1, you can say it as 2 times increased odds or 3 times increased odds based on the value of your odds ratio. Clear? Okay, any more doubts for chi-square? We can move to the next one. Okay, so next we are going to do the next statistical test, which is the, okay, I will give you a scenario. I want you to answer this. See, now you want to see the association between marital status, okay, between marital status and the nicotine dependence score, not the categorized one, but the nicotine dependence score over here. Okay, so this is the raw score based on the computation of all the questions, 8 questions or the responses. If you compute and get, it is the raw score of this thing, which is measured on a scale in a continuous variable. Okay, now I want to find the association between this score, this value, and marital status. Marital status has 2 categories. Okay, 1 is unmarried and 2 is married. So what statistical test should I use? Yes, ma? What test?
Student t-test, sir.
Exactly. So we are going to use independent sample t-test, also known as student t-test. So we are going to go to compare means. We are going to go to independent sample t-test, and we are going to give the marital status into this grouping variable. Okay. And I'm going to keep the continuous variable, which is the score over here. And I'm going to define these groups. Okay. I'm going to give it as 1. I'm going to give it as 2. And I'm going to give okay. So this is the interpretation of the independent sample t-test. So for unmarried, this is the mean, this is the standard deviation. For married, this is the mean, and this is the standard deviation. So here we have the asymptotic value, p-value, to be 0.000. So the mean difference in the nicotine dependence, the mean value in the nicotine dependence score you have over here, and you can say that the difference in the nicotine dependence score between unmarried and married is statistically significant at 95% confidence interval. Okay, so the nicotine dependence score is differing between these two, also known as mean difference. Okay, so that this mean difference is statistically significant at 95% confidence interval, telling you the same thing as chi-square. There's a statistical significant relationship between marital status and the nicotine dependence score. Okay, but I think normality test has been covered in SPSS. So can you see what is wrong with this? Can anyone identify what is wrong in this?
Standard deviation is more than half of mean.
Exactly, exactly. Okay, so this is clearly not normally distributed. Okay, because when I was a PG, I used to like go for t-test for each and everything. Okay, So when I put one of the journal asked that standard deviation is more than half of the mean, how could you use a independent sample t-test? So that is when, rather than going for the normality test and going for Kolmogorov-Smirnov or Shapiro-Wilk, doing all those things, having a simple look at the mean and standard deviation will give you an idea about the normality of the distribution. Okay. So in these things, what I will do? Any idea? What is the alternative of independent sample t-test?
Man-Whitney U-test.
Okay, yes, exactly. Man-Whitney U-test. Okay, so I'm going to go to analyze. I'm going to go into non-parametric test, and I'm going to go into the independent samples. Okay, I am going to go into the non-parametric test. I'm going to go to the independent sample, and here I am going to give free Fagerstrom score over here, and the groups I am going to keep the marital status. Okay, so this nicotine dependent score over here and marital status over here, and just I am going to run this. Okay, here you see over here, here it is saying that, p-value is 0.000, it is statistically significant. So here, you no need to like mention any kind of values or anything. You just can mention the median, okay, and interquartile range. Listen carefully. In case of normality of the data, you use the t-test. And you will say that mean plus or minus standard deviation and the p-value. Okay. In case of normality is not there, then you have to interpret with median and interquartile range following by the p-value obtained from the Man-Whitney U-test. If you are finding a relationship between a quantitative dependent variable and the qualitative independent variable, which has only two categories. Marital status, qualitative variable, two categories. Nicotine dependence score is a quantitative variable. So instead of using t-test, we have used this. So do not use the mean value, do not use the standard deviation. Any idea why we are going for the median instead of mean? Yes?
Because it's not normally distributed.
Yes, ma. Anything else?
Because it's not normally distributed.
Normally distributed. One more thing is, median is not much affected by the outliers. Okay. Median is not much affected by the outliers. See, if you have a mean, for example, you take some 20 people, and among the 20 people, if you 15 people have scored between, for example, like 50% to 70%. 15 people have scored between 50% to 70%. Okay, so among these 50 people, if you see, the mean value will be like 61 or 62. But the whole 20 people, 15 people, 50 to 70. The 5 people alone, among which they have scored something like in single digits. Okay, 3, 4, or 5. So because of this, the mean value will go down. Will not be 61 or 62. Will go down. Okay, will go down. But the median value will be unaffected because median value is the middle value. Okay, since median value is the middle value, it is unaffected by the outliers. Okay, so that is why while reporting a non-normally distributed data, we have to use the median value. Okay, for example, if you don't want to categorize nicotine dependence into low or high, and you want to publish the paper, you can do so. Okay, you can say that in unmarried people, the score of nicotine dependence is higher when compared with married people with a median of. Okay, so there is nothing wrong and there is no hard and fast rule that you have to classify. Always keep in mind, I always tell my PGs that don't forcefully classify the scores. If, for example, if you take a quality of life questionnaire, You all would have heard about quality of life questionnaire, right? WHO questionnaire. It doesn't have some kind of hard and fast classification. Okay, above this score, we have the good quality of life. Below this score, we have the poor quality of life. It doesn't have a hard and fast one. So in those times, you have to use you have to keep the score as such and do the analysis. So you will go for t-test and linear regression. So you have to keep this in mind always, because scores are usually not normally distributed. So you have to know how to report them. Okay, clear? Any more doubts you have?
Sir,
So-
for the normality test for all the dependent variables, we have to do it before we check for the association.
Yeah, that's what. Before you go for the association, if it is a quantitative variable, if your dependent variable is quantitative, you have to check the normalcy. You have to check the normal distribution. Only then you have to decide what test you are going to do. Okay, so now the independent variable had only two categories. Marital status, you have the married, you have the unmarried. Now, what if I am going to choose the occupation? Okay, so here if I go, occupation has three categories. Okay, unemployed, skilled workers, and professional. Now I want to find the association with nicotine dependent score. Consider it as normally distributed. What test am I going to use? My nicotine dependent score, which is a quantitative variable, is normally distributed, and I have an independent variable. What?
ANOVA.
Yes, exactly. Okay, you will be using ANOVA.
So if you
So I'm going to analyze. I'm going to go into compare means, and I'm going to give one way ANOVA. Okay, here I'm going to keep the occupation over here. And I'm going to keep it over here. Okay, see, now we are not going to go into this LSD, bond ceremony and all. Okay. So here I'm going to give okay. Now it is saying that it is statistically significant. Statistically significant. So what I have done is wrong. I am just hypothetically I said that the nicotine dependent score is normally distributed. But it is since it is not normally distributed, so I'm going to go into analyze. I'm going to go into non-parametric test. I'm going to go into independent sample, and I'm going to remove the marital status, and I'm going to add the occupation over here. Okay, and I'm going to give 1. Here it has already utilized the Kruskal-Wallis test. Okay, it has already utilized the Kruskal-Wallis test in place of ANOVA, and again it is found to be statistically significant. Okay, statistically significant. So now we saw, I'm just going through the basics. I mean, going through what we saw till now. Independent variable is qualitative, categories. Dependent variable is qualitative, categories. We did chi-square. We saw the chi-square. We saw the odds ratio. Next, the dependent variable is quantitative, numbers. The independent variable is categorical, and 2 categories. Normal distribution, we saw the t-test. Non-normal distribution, we saw the Mann-Whitney U-test. And again, dependent variable, quantitative. Dependent variable has quantitative numbers. Independent variable has 3 categories. So you go for one way ANOVA in case of normal distribution. If not, you go for the Kruskal-Wallis test. Clear till now? Clear?
Sir, again, to discuss the one-way ANOVA steps in SPSS.
You want me to show again?
Compare means?
You want me to show again?
Yes, sir.
Yeah. Analyze, compare means you have the one-way ANOVA. Okay. and you give the quantitative variable over here, continuous variable, and you have the categorical variable over here, and you give okay. And you go down and see the output over here. You see the output over here, and you see the p-value over here, which shows that occupation is associated with nicotine dependent score. Okay,
Yes, sir.
clear?
Clear, sir.
So next, what we are going to see about paved t-test. When do you use paved t-test? Yes? Yes, any idea?
If dependent variable are continuous, the independent variable two groups.
Okay. So in paved sample t-test is ideally used for before after. Okay. So here, before I gave health education, this was the nicotine dependence score. After I gave the health education, this is the nicotine dependence score. Okay. Now I am giving okay over here. And now I am getting the statistical significance. So there's a statistical significant association between the nicotine dependence score before and after intervention, which shows that there is some kind of change which has happened. If you see over here, the nicotine dependence score before had a mean of 4.85. After I gave the health education intervention, it has decreased to 3.11. So that decrease was found to be statistically significant. Again, this is a non-normally distributed data, so I cannot use paved sample t-test. So instead of this, what I should use? Yes?
Wilcoxon.
Wilcoxon test.
Exactly. So what I will do, I will go to analyze. I will go to non-parametric test. I will go to something called related samples. Okay, I will go to something called related samples, inside which I am going to put these two scores. These two scores over here. And I'm going to give run. So now it is showing that I have used the Wilcoxon rank sign test and found the association to be statistically significant. Okay, so this is how you use the Wilcoxon signed rank test for paved data, before after data. Okay, so this is the Wilcoxon rank sign test. Okay, so now again, what I'm going to do is, see, if you see over here, you have the nicotine dependent score before intervention and nicotine dependent score after intervention. So before intervention, I have categorized them into having dependence or no dependence. After giving the intervention, I have categorized them into having dependence and no dependence. For example, let us see. Before intervention, I have 116 people found to be dependent on tobacco. Okay. After intervention, I am having only 46 people. Okay, so it has reduced from 116, it has reduced to 46. Okay, so I now want to find the association between this. So both are paved data. Okay, paved data before and after, and both are qualitative. So what statistical test am I going to use over here?
McNemer test.
Exactly. Excellent. So I'm going to go over here, descriptive statistics. I'm going to go to the cross tabs. Okay. Now I'm going to keep the post Fagerstrom scale into the column. Sorry, not this one. the post-Fagerstrom categorical variable into the column and pre-Fagerstrom categorical variable into the rows. And inside the statistics, instead of clicking on chi-square, I am going to click on McNamara. Okay, and I am going to give OK. So here, if you see, the McNamara test, the p-value is statistically significant. P-value is statistically significant. And if you see over here, before intervention, the high dependents were totally 116 people. Okay, 116 people, among which 95 people have moved to low dependence. Okay, this is just a 2x2 table giving you an idea about how much the data has shifted from pre-intervention to post-intervention. Pre-intervention to post-intervention, and this is going to give you the chi-square. Now, if I go and show this table which was shared by Dr. Vijay Karthikeyan, now we have seen about all these tests we have seen. Okay, in SPSS, we have seen the independent sample. Yes.
Sir, in this all the tests we have seen one thing common, that irrespective of the parametric and non-parametric test, if the results is significant in the parametric, it's same variables having the significant test in the non-parametric also.
Yes, exactly. See, the thing is, sometimes or most of the time, it will be significant in both. Sometimes it may not be significant, but the reason why we say that we have to use non-parametric is because a false association, if you are using the t-test for a non-normally distributed data and saying that association is there, will lead the scientific literature into the wrong side. So that is why we always used to say that if normality is compromised, go for the non-parametric test. You may find significant in both. But you have to tell that you have used the non-parametric test since the data was normally distributed, and you have to refrain from using mean and standard deviation. Instead, you have to use the median and interquartile range. Okay. There are some instances, in my personal experience, I am saying, there are some instances in which the significance has differed. Okay. In parametric, it may be significant, but in non-parametric, we may lose the significance in the non-parametric test. Clear? Okay. So shall we move to the next one? Yes, any doubts you have till now? Okay. Okay then. So next we are going to see about the correlation and regression. Okay. Before that, I want to tell you that what is the purpose of regression? Yes.
We should be able to predict the value of the dependent variable from the independent variable.
Okay. So if you would have gone through some research articles, you would have seen something called adjusted odds ratio and something called a regression model. So the reason why we are doing, you are finding the statistical significant association by using the bivariate analysis. Bivariate analysis is what I showed till now. Okay, chi-square, one qualitative, one quantitative, chi-square, t-test, ANOVA, all these things are going to just tell you that there's a statistical significant association between a independent variable and a dependent variable. Okay, but regression is going to tell you what is the impact of 5 or 6 variables on the dependent variable. Okay, for that you have to understand that, for example, if you have some 10 independent variables, you have to do the bivariate analysis. Okay, you have to do the bivariate analysis and find which variables are found to be statistically significant. For example, let us take, I'm going for the cross tabs and I'm going for nicotine dependence category over here. And I am taking that occupation, education, marital status, socioeconomic scale, age of initiation of tobacco, not this one. So just I'm taking these 4 variables and I'm using the chi-square. Okay, so okay, occupation significant, education significant, marital status significant, socioeconomic class also significant. So what this says that each variable has a univariate association. Okay, which means that separately, each variable has an association with a dependent variable. But when all of these variables are present together, how much the dependent variable is influenced? I will say it again. If all these variables are present together, how these variables influence the dependent variable, that is what you are going to see in the regression. Sometimes among the 10 variables, only 4 variables you would be finding statistically significant association, either by chi-square or t-test or ANOVA, whatever. Only those variables you will take it into the regression. Okay. So first we will see about the logistic regression. Okay. You have the here you in the analyze, you go to regression, you have the binary logistic, you have the multinomial logistic. In binary logistic, okay, in binary logistic, I'm going to keep the nicotine dependence category over here. And again, what are the variables which were found to be significant? We had the occupation, we had the education, we had the marital status, and we have this classification. Okay, so all these are categorical variable. So I have to go to this categorical, I have to select everything, and I have to say that these are categorical variable. So I have coded it as 1 and 2, 1, 2, 3. Okay, middle class, say if you see over here, 1 is middle class, 2 is upper middle class, and 3 is upper class. Ideally, in the independent variable, if you see over here, the last one will be the reference because that is the least risk. That is the least risk in case of nicotine dependence. Okay, each and every study title, study design, or study hypothesis which will have different definitions of what constitutes the least risk and the highest risk. For this one, upper class is the least risk and middle class is the highest risk. Okay, so here you have to mention which is the reference category, whether it is first or the last. Okay, since I have kept it at the last, upper class is the least risk, I will keep the reference category at the last itself. Okay, and I will give continue. Now if I will go to the options, then I will say that I will have to look for the confidence interval of the odds ratio, and I have to do something called Hosmer-Lamshaw goodness of it. Okay, so as I said before, I am not going into the details of regression. I am just teaching you what you need to know for publication. If you want to know in detail about each and everything, classification plot, case-wise residuals, correlation estimates, and all those things, we need another 1 hour to deal with regression alone. Okay, so I'll just try to keep it as simple as possible for you. And again, you have the methods over here. I'm not going to go over the details. The thing is, some journals know when they are asking for submission, they are asking what type of regression method have you used? So you have to say enter method. You have to say enter method. Okay. So, and I give okay over here. So again, this is the regression. So first 175 are included in the analysis. Okay, next, if you see over here, I am just going down and showing you only what you need to know as of now. So here you have the Hosmer-Lamshaw test. You have the Hosmer-Lamshaw test and you have the R-square value over here. Okay. So what is this R-square value? R-square value is 0.242. Okay. And Hosmer-Lamshaw is 0.517. So what you need to understand is 24% of the variance in the dependent variable can be attributed to the independent variables, which are occupation, education, marital status, and the socioeconomic status. I will come again. 24%, this Nagelkar R square, this 24% of the variance in the dependent variable can be attributed to these independent variables. So this is the R square. Next is the Hosmer-Lamshaw test, goodness of fit. So goodness of fit should not be significant. Keep in mind, goodness of fit, Hosmer-Lamshaw is a type of chi-square test. It should not be significant. If it is not significant, then you can say this model or all these variables together is capable of predicting the dependent variable. Okay, this occupation, education, marital status, and the socioeconomic status, all these variables together are capable of predicting the dependent variable over. Okay, next, coming to the variables in the equation. This is the table which you have to be more concerned about. This is the table which you have to be more concerned about. For the occupation, we have three categories. Okay, so the first, as I said before, we have set the reference category to the last. Okay, so here you have over here. See, if you see the table over here, if we saw statistical significance for all these in the bivariate analysis. Bivariate means chi-square. In the chi-square analysis, we saw statistical significance of all these variables. But if you see over here, in the regression analysis, only socioeconomic status was found to be significant. Only socioeconomic status was found to be significant, and all the other variables were found to be, marital status is also significant. Only marital status and socioeconomic status are found to be significant. Occupation and educational status are not significant. So what it means to say is, univariate analysis, when you see occupation and nicotine dependence alone, the statistical significant association we found in the chi-square analysis, it is when they are seen separately. But if you see multivariate regression, multivariate means multiple variables. Okay, there you found all the four variables were found to be statistically significant. When you consider the cumulative effect of all these four variables on the dependent variable, only marital status and socioeconomic status are capable of predicting the dependent variable, and occupation and education are not predictors of dependent variable. So note down the terminology I use. In bivariate analysis, you are saying that only statistical significant association is present between marital status and nicotine dependence. Okay, and socioeconomic status is found to be associated with nicotine dependence. But after doing a regression, you can say that marital status is a predictor of nicotine dependence. Socioeconomic status is a predictor of nicotine dependence. Okay, and here you have the exponential beta. This exponential beta, it's the odds ratio. This is the odds ratio. Okay, so if you see over here, marital status has an odds ratio of 3.1 with a 95% CI lying between 1.3 to 7.3. If you see the BG Prasad classification, you can see over here, it had three categories, right? So in that, the third one will be the reference. So you leave that. Okay, and again, if you see the other two socioeconomic classes, both are found to be protective. Both are found to be protective, and you have the 95% CA over here. Okay, so this interpretation will be same as I said before. For the protective, you are going to say 56% less likely. Okay, and 32%, 5% less likely, and 32% less likely. Okay, and for this, you are going to, 20, I saw the, I'm extremely sorry. 20% less likely and 83% less likely. And for the marital status, you are going to say, okay, in the odds ratio, you are going to say 3.1 times increased odds. Okay, so I will repeat again from the beginning. Okay, you go to analyze, you go to regression, You go to the binary logistic regression. You put the dependent variable over here. You put the independent variables over here. And you go to the categorical and say that all these four are categorical variables. And for each variable, define the reference category. It may change based on you. Maybe you may have coded like what I may not have coded. Okay, Kala. So based on what you have coded, you have to define the reference category for each and everything. And then you have to click OK. So big tables will come. First, you have to go to the Osnov lamp show, check significance is there or not. Not significant, well and good. This model is capable of predicting the dependent variable. Then you go and check the R square, 0.24. So 24% of the variance in the outcome variable can be explained by these independent variables. Then you go down and check how many are statistically significant. Okay, for educational status, not statistically significant. Occupation, not statistically significant. Marital status, significance is there. Look at the odds ratio. Protective or risk. So 3.1 times increased risk. BG Prasad, socioeconomic status, significant. So whether the risk is, whether it is protective or risk. Since the odds ratio is less than 1, it is protective.
So,
Okay.
sir, we will comment like this: 1 point in educational status, 1.8 times more odd of having this
No,
outcome.
sir. See, have a look. This 1.8
Yes, sir.
times, 1.89 times you are saying, right? This is not significant, 0.61. Okay, so you should always have a look at the p-value. Only if the p-value is significant, look at the odds ratio. Only if the p-value is significant, look at the odds ratio. Okay, here education is not significant. Here education is not significant. And occupation is not significant. You look at only the p-value which is significant, then you look at the odds ratio, whether it is risk or protective. Clear, sir?
Yes, sir.
Sir, in BG Prasad recorded, in that one now, BG Prasad recorded is coming as significant, BG recorded 1 is coming as significant, and BG recorded 2 is not coming as significant. So what does that mean?
Yeah, that I have to go and check how I have coded the variables. So here if I see, I have the middle class, upper middle class, and upper class. Okay, so it is coded as 1, 2, and 3. Okay, this upper class is taken as the reference category. Okay, so this is 1 and this is 2. So if I go back over here, here this one denotes lower class, and this one denotes I'm again middle class. Sorry. So this one denotes middle class, and this 2 denotes upper middle class. So only middle class is found to be statistically significant.
Okay.
Okay, not the upper class. So that is why coding is very, very important in case of regression. Coding is very, very important in case of regression. In the beginning, no, you people ask me, right, sir, why should I code? I can have it like middle class, upper middle class, and all that. String variables, which has only name, which has only letters, cannot be taken into any kind of analysis. Only if you code, it can be taken into analysis. Clear? So any doubts in binary logistic? Sorry, binomial logistic?
Sir, in this, where is the upper class value, sir? In that BG recorded.
Upper class values is not there. Upper class is the reference value, right? The upper class is the reference value.
Okay.
Okay, so you won't get the values for that.
Sir, one doubt. How will you decide that this is the reference value? How to take this as a reference value?
That is what I showed you, right? In the regression, you go for the binary logistic. Here you have all these values over here. So all these values over here, right? You go into the categorical and BG Prasad. Here I have the reference category, last or first. Okay, so here if I go and see, here you have the middle class, upper middle class, and upper class. My literature tells that middle class and upper middle class are at a higher risk of nicotine dependence compared to upper class. So what I do is I take the upper class as reference I mean upper class as reference category. So I am clicking last. No, you are saying that no, sir, middle class la da risk adhigam. Middle class only are nicotine or more prone to develop nicotine dependence. Abdina, I will keep it the first one. Okay, it all depends on your title, hypothesis, and your scientific literature. For example, if I go for depression, nowadays you can say that upper class people are more prone to develop depression because of the rapid urbanization and modernization and use of lot of different gadgets and all that. I can say that upper class people are more prone to develop depression. Now that time I will change that upper class people are at higher risk. Okay, then I will change the middle class as the reference value by clicking first over here. Understood? So this defining the categorical reference category is in this column. Categorical, if you click, based on your assumption, you can decide the reference category. Okay, but once you keep upper class as the reference value, the odds ratio for that will not come over here. The odds ratio for that will not come over here. Okay, clear?
Yes, sir.
Okay, now we will move on to the multinomial logistic regression. Okay, we will move on to the multinomial logistic regression. Okay, in multinomial logistic regression, what I am going to do is this prefagoston. No, not this one. Wait. So this is the raw data. Okay, this is the raw data in which I have classified the phagostorm scale into what it initially was classified as per the creator of the phagostorm scale. Okay, so he has told that high dependence, moderate dependence, low to moderate dependence, low dependence, and no dependence. Okay, so we have how many categories over here? We have 5 categories. Okay, we have 5 categories over here. So among these 5 categories, you are going, which will you keep it as the reference category? Anyone? Now this is the dependent variable. Okay, this original grading is the dependent variable. So which am I going to keep it as the reference category?
No dependence.
Exactly, no dependence. Okay, so as Dr. Kavin Kumar sir pointed out, you have to do multinomial regression when your dependent variable is qualitative and has more than 2 categories. Okay, so here you have the phagostorm original grading. Here you have the phagostorm original grading, and the reference category is by default set to last. Okay, so as I showed here, the last one is the no dependence. So last category is we have instructed SPSS to use the last category as the reference category. Okay, and now I can put all the variables. See, in factors and covariates, you will have a doubt. Okay, so what variable should I put inside the factors and what variable should I put into the covariates? So whatever has more than 2 categories, for example, occupation and education has more than 2 categories. So that I put into the factor section. And what has only 1 category, only 2 categories, I put into the covariate section. And all the continuous variables also can come in the covariate section. Okay, clear? Any qualitative variable which has more than 2 categories will go into the factors. The
So
Yeah, tell me, Ma.
Sir, if we need to study the protein expression in many groups, like 2 or 3 groups, and we need to study many parameters like histopathological parameters or socio-demographic parameters. So, do we need to go for each parameter for? I mean, do we need to go for separate test each parameter, or actually I'm confused about it.
What is your dependent variable?
Yes, sir.
What is your dependent variable? Outcome variable.
Expression, protein expression.
2D expression.
Protein expression among many groups.
Okay. It
2
is
or 3 groups.
quantitative. The outcome is going to be quantitative or qualitative?
Quantitative.
Quantitative. So it is going to be numbers,
Yes, sir.
right?
Yes,
So
sir.
it is
Yes.
going to be
No, level,
numbers.
more, high, moderate, weak, as per that.
So you are going to have categories,
Yes, sir.
right? Some 4
Yes,
or
sir.
5 categories like normal, low, medium, high, very high, something
Yes,
like that.
yes,
Yes.
yes, sir.
Yes. Okay. For that, first you have to do the chi-square.
Okay,
Okay. First you have to do the
okay, sir.
chi-square. If you are independent variable, for example, you are grading, which you are saying, no, normal, low, high, and all that is the dependent variable. If you are going with the gender, male and female, you will use the chi-square. Okay. If it is
Okay,
age is a continuous variable, right? So if it is a continuous variable and your dependent variable has more than 2 categories, you do what? ANOVA.
okay,
Okay, you do ANOVA. So again, you have to look at the independent variable, how it is. Categorical, go for chi-square. Quantitative, numbers, what you are, sorry, more than 2 categories, ANOVA, 2 categories. So it depends on how your independent variable is. Your dependent variable is categorical. Your dependent variable is categorical. So how the independent variable is? Okay, if the independent variable or
okay,
the
sir.
variable you want to see is continuous or quantitative, based on that you decide on chi-square or whatever you have. Okay,
Okay, sir.
and from that, whatever is found to be significant, you have to bring into the regression model. And regression model, you have to keep the dependent variable over here. And here in factor and covariates, you have to define. You have to define. Okay.
Okay,
Clear?
sir. Yes, sir. Thank you.
Okay. So in this, so we have more than 2 categories I have kept in the factors. And here the continuous variable and 2 category variable I have kept it over here. And here we have to click the statistics. And here again, we saw Hosmer Longshore, right? In binomial logistic. Here you have to click it over here. You can have the pseudo R square and all that confidence interval, everything can be there. So again, I am not going into these details. Okay. And again, the interactions I am not going to deal with. So you just see these things. Criteria, I'm not going to go into this. And dispersion scale, I'm not going to touch. And bootstrapping, I'm not going to touch. Okay, and model, this is the interaction model. This is also not going to touch. So why I'm showing you this? These are all advanced concepts in regression, which will take a long time to teach. We know this, maybe CATCOM can organize something like advanced course in which we can cover all these. Okay. So now I'm going to give OK over here. So I will go up. So this is the regression model. So again, what you have to do, you have to go and see the goodness of it. So in the goodness of it, if you see over here, the Pearson and the deviance, both are found to be statistically significant. So ideally, what you are saying that these models, the variables which are contained in this model are not good enough to predict the outcome variable. Okay, are not good enough to predict the outcome variable. So this is regarding the goodness of it. Okay. So as I showed before we had non-significant. So it is like ulta, conversely, in chi-square and all, significance we will see and say association is there. In goodness of it, if significance is there, this model is not good enough to predict. Okay, then you go to the R square, so 0.626, so 62%. So this model, 62% of the variance in the dependent variable can be attributed to the independent variables which are contained within the model, which are what all we put, occupation, marital status, age, and all that. Okay, so this is the regression model. So like instead of going over here, I will just minimize this and I will show you a regression model for you. Okay, just 2 minutes. I will just stop my screen share.
Hello, sir.
Yes.
No, sir. That's I'm checking out. Is there anything
Oh.
going wrong? Okay.
No. I just stopped screen share because I want to show something.
Okay. Fine. Okay, sir. Sure.
Yeah. Okay, so now we have the categories over here. We have the low dependence. So we have the no dependence, low dependence, the categories are switched. Okay, so you have the high dependence, moderate dependence, and low dependence. Okay, so in high dependence, what is the association between high dependence and marital status? What is the association between high dependence and age? What is the association between moderate dependence and marital status? What is the difference association between moderate dependence and age? If you have a look at over here, high dependence and marital status, not significant. High dependence and age is found to be significant. Follow me clearly. It will be a little bit confusing for you. High dependence and marital status is not significant because the p-value is 0.49. High dependence and age is found to be significant. Odds ratio is also found to be on the higher side. Okay, and coming to the moderate dependence. Again, moderate dependence, marital status is not significant, age is significant. For low to moderate dependence, again, marital status is significant and age is also significant. Low dependence also has marital status significant and age as significant. So these are the odds ratio and these are the 95% CA. Okay, so the challenge is how will I create a table for this? Because we all are ultimately going to do the analysis and create a table, right? We all want to know how to create a table for this. Okay, so any doubts you have in this? Forget about this beta, standard error, walled, degree of freedom and all. You don't need that for writing the table or telling your interpretation or anything. Any doubts over here? Dependent variable, more than 2 categories. You had 5 categories. So the reference category is no dependence. So for all the 4 categories, association with the independent variables you see over here. So this is how you have to write the interpretation for a multinomial regression model. Here, if you see, the dependent variable has three categories: normal weight, overweight, and obese. Normal weight, overweight, and obese. Okay, so this is the overweight over here. This is the obese over here. And here you have the adjusted odds ratio, 95% confidence interval, and p-value. Same for obese, you have the adjusted odds ratio, 95% CI, and the p-value. So here you have the socioeconomic class, class 1 and class 2. What is the odds ratio? What is the 95% CI? Odds ratio, 95% CI, p-value. So this is how you have to write. Because SPSS gives you like this. The dependent variables will be like this. Okay, will be on the rows. And your independent variables, you will see over here. Okay, so you have to arrange it like this. You have to arrange it like this and define for
So,
each.
Sir, that
interrupt you.
screen is not shared, is it?
Yeah, sir. I just want to ask that the adjusted odds ratio for 95%, like how we will gonna comment like this? Like just please repeat now.
So can you just
See the
share that screen, sir? The table which you are describing is not shared.
it's not shared, I'm sorry. Are you able to see the table over here?
Now it is visible, sir.
Now it's visible.
Oh, sorry. I have then shared only the SPSS screen. So this is the table. So you have the three categories. You have the normal, overweight, and obese. Normal will not come inside because that is the reference category. You have the overweight and obese. So for each independent variable and its classification. For example, the first variable is the socioeconomic status. So you have the class 1 and class 2. So for class 1, what is the odds ratio? 95% CI p-value. For class 2, 95% CI and p-value for overweight. Next, you have to go for the obese. Okay, likewise for each and every independent variable, you have to write the adjusted odds ratio, 95% CI and p-value. If it is, yeah, tell me someone about to ask something. Nothing? Okay, done. So this is so this is how you will interpret the, you have to construct a table for multinomial logistic regression. Okay. So as everyone are saying to you, regression is just a little advanced statistic. Usually, before and all, we used to stop with only descriptive data. Even if you give only the frequency percentage, they will accept for publication. Now they are improvised. In 2020, it got improvised, and they were asking for chi-square, t-test, p-value, and all that. Now, without regression, none of the paper are getting accepted. So that is why, as PGs or faculties, you have to have a deeper understanding on how to do regression and how to construct tables. Because most of my PGs know they will be able to do this thing because it is like computer skills, right? So I'm going to do this, go here and go there, and whatever you're going to put and your values are going to come. The thing is how you are going to construct a table matters. And multinomial regression is the most difficult table to construct because you have many categories of the dependent variable. So whatever categories of the dependent variable you have, you put it over here. Okay, for example, our example, if you take, you have the high dependence, moderate dependence, low dependence, everything will come over here. And here you have the marital status. Here you have the marital status will come over here. And here unmarried and married will come over here. And occupation will come over here. Categories of occupation will come over here. And for each category, for high dependence, what is the odds ratio? For moderate, what is the odds ratio? For low dependence, what is the odds ratio? You have to mention. The table is going to be a bit big, but all these you have to make sure you keep it inside the table. Okay. No. I can't hear you properly. Come again.
For multi-member logistic regression, multi-member logistic dependent category. Dependent variable is categorical.
Yes, in multinomial logistic regression, you need categorical data.
Dependent is categorical. Independent
No, dependent is categorical.
is categorical.
Dependent is categorical. Yes, independent, it can be either continuous or categorical. Okay. The rule is for logistic, you have to make sure that the dependent variable is categorical. 2 categories, binomial logistic. More than 2 categories, you have to go for multinomial logistic. Okay, clear. So now we will go quickly to the linear regression. So regression, linear. Okay, so linear, what we are going to see? We are going to go into the Fagerstrom raw scores. So here the dependent has to be quantitative. Quantitative means you have to make sure that the dependent variable is in numbers. Okay, quantitative. So here you are going to take the dependent inside and you are going to take again occupation, education, marital status, whatever you have, you can take it inside. You can take it inside, and in statistics, you can have some, okay, collinearity, variance, inflation factor and all. We don't have time to deal with those. We will just click on the confidence intervals. Okay, we will just click on the confidence intervals. In this also, we don't have time to check over this, and I'm going to click OK. So this is a little confusing and it is difficult for you to understand. So just follow closely. So now what I have done is, I have the dependent variable is Fagerstrom scale, the raw score with the dependent variable. Okay, and the variables I have entered are marital status, occupation, and educational status. Okay, again, you have the R square value over here. So what is R square value? I said 0.18 means 18% of the variance in the outcome variable can be explained by these marital status, occupation, and educational status. Okay, and again, you are going and checking for the, this is the regression table which is found here. Okay, so if you see, we have nothing called odds ratio. Yes, is there anything called odds ratio over here? Nothing. We don't have exponential beta. We don't have exponential beta. Okay, so we have only the occupation, education, marital status, and something called unstandardized beta coefficient. Okay, unstandardized beta coefficient. So first, even the same rules applies for odds ratio. We are going to look at the variables which only has the p-value as significant. We are going to see the variables which has the p-values as significant. So what are the variables which has p-value as significant? 0.026 education and 0.000 marital status. So only these 2 variables are found to be statistically significantly associated with Fagerstrom score. So I am going to look at the educational status. I am going to look at the educational status. So it is minus 0.654. Okay. So what we are meaning to say is, we have to first understand the categories the educational status have. See, the educational status has illiterate, primary school and secondary school and higher secondary and graduate. Okay, so here what regression understands is higher. Okay, so first I will delete with marital status so that you understand clearly. See, this marital status. So 1 is unmarried and 2 is married. Okay, 2 is married. And here you have the marital status to be statistically significant and you have the beta coefficient to be 2.2. Okay, so what we are meaning to say by this is, those who are unmarried have a 2.2 unit increase in the Fagerstrom scale score when compared with those who are married. Okay, so each unit change in the independent variable, follow me closely, each unit change in the independent variable, how much change will it produce in the dependent variable? That is what is going to give with this table. So in marital status, each unit change means from unmarried to married. You have only 2 units over here, right? From unmarried to married, if you shift, there is going to be a 2.2 units increase in the score. Okay, 2.23 units increase in the score, which says that unmarried has a 2.23 increased score when compared with unmarried. Can you understand? See, in exponential beta, adjusted odds ratio is 2.23. You are saying that marital status has a 2.23 times increased odds of having nicotine dependence. In case of interpretation of beta coefficient, 1 unit change in the independent variable, how much change does it produce in the dependent variable? So 1 unit change from unmarried to married. So it is going to increase by 2.2 units in the score. In case of educational status, you have 5 categories. You have 5 categories. So ideally, in the regression model, higher the number, higher is the highest number only, it will take it as the reference category. So each unit change from illiterate to primary, from primary to higher secondary, from higher secondary to high school. So that, sorry, from high school to higher secondary, that change will have a 0.6 decrease in the score. Okay, decrease in the score. So this, I mean, since I have shown you an example of one of the, what is that? Educational status score, it may be a little confusing for you, but now I will just show you one table for you which you can easily understand. So I will just stop this. I'll show you a table. Okay, so this is how you construct a linear regression table. This is how you construct a linear regression table. So here there is an association between self-reported scores on SRQ20. Okay, this is a scale which is used to measure the psychosocial well-being. Okay, so in this score, I am having all these variables as the independent variables. So age, you have the beta coefficient as minus 0.18. So it shows that 1 unit of increase in age decreases the score by minus 1.8. Since age is a continuous variable, you can say that 1 unit increase in the age will decrease the score by 1.8 units. In case of male sex, males have a minus 1.5 decrease in score when compared with females. Males have a minus 1.5 unit change in score or decrease in score when compared with females. Here, marital status unmarried. Unmarried people have a 1.8 unit increase in score when compared with married people. Okay, likewise, each and every variable you have to interpret. If you see here, I have not put any kind of categories over here. In regression model, you should not put like marital status, married, unmarried. Upon having children, children in home? Yes, no. Okay. So marital status unmarried and married means married is the reference category. So there's no need of mention of another row and writing unmarried is unnecessary. So that is why in linear regression, you have to make sure that you mention only the risk category over here. In marital status, unmarried and married, which is the risk category? Unmarried. So show only that. Having children in home, yes, no, which is the risk category? Yes. So have only that. Type of family, nuclear and joint. So which is the risk category? Nuclear. Have only that. Consumption of tobacco, yes, no, yes, have only that. Okay, meals per day, less than 3 meals, greater than 3 meals, which is risk less than 3 meals. So only the risk category of the independent variable should come in the table. And the beta coefficient, t value and the p value should come. T value also now you may not want to write, or some journals may not ask, but p value should be there. Okay, and look at whatever is significant only, you mention the beta coefficient. Beta coefficient. Okay, and again here WHO well-being score and related variables. So in the down I have written, see, R square value is 0.276, F value is 3.712, P value is less than 0.05, statistically significant at 95% confidence interval. So how am I going to write this in the result section? The result section, I am just going to say that on multiple regression analysis, variables like so and so, so and so, so and so were found to have a statistical significant association with SR2 scores. Based on R square values, 57% of the variance in the SR2 scores can be explained by the predictor variables. Same like in multiple on regression for WHO well-being scale. This gender, marital status, all these things were found to be a significant association with well-being score. Based on R square value, 27% of the variance can be explained by these predictor variables. Okay, so this is how you do the linear regression and explain based on R square. Okay,
Sir,
explain. Yeah, tell me, Tom.
sir, as you mentioned in the table that male sex having the 1.26 units compared to female. So how will you say like less than 3 meals per day? Like what will be the comparator? Like 1.2 that's compared to which? Like in the male sex you said compared to female sex 1.26 units having the psychosocial wellness. So
Yes,
in
yes.
less than 3 meals per day will be considered as a 1.2 comparator will be like whom? Like
Compared to females.
okay, everything will be with females.
Yeah, females. Male sex. See, I have written only the male sex because I have my risk category is male. Okay, gender has two categories, Lapa. You have the male gender, you have the female gender. I have written only the male gender because male gender is the risk category.
Okay, so
Okay.
the less than 3 meals per day will be with female gender having the less than 3 meals per day.
Yeah. Oh, no.
Okay.
Less than 3 meals per day is another independent variable.
Okay, that's what I am asking, sir. Less than 3 meals per day compared to what variable we are saying that it is
More than
having a
3 meals
more.
per day. More than 3 meals per day.
Okay, like that. Okay.
Yeah. That's what I'm saying. While constructing a table for linear regression, you should not use it may not be a good idea to use the reference categories in the table.
Yeah.
Okay, I will show you another table for you. Because only if you see, you will understand. See? Here, if you see, this is a multiple logistic regression analysis. See, you were asking, right? So this unit change is minus. See, if you compare logistic regression and linear regression, sometimes no. As I said before, odds ratio goes less than 1, right? So less than 1 means what you will say, it is protective. Same concept with the beta value. Same concept with the beta value. If beta value goes negative, it becomes protective. So here, if you see male and female, I am saying that when there is a switch happening from male to female, there is a 1.5 score is decreasing, which means that females, they have a 1.5 score increase compared with males. Yes, you see the contrary over here. So male gender is protective because from male to female, if you go, females have an increased score when compared with males. So that is equal to odds ratio. That is equal to odds ratio coming less than 1. Okay, for that only I have showed you this table. Okay, this is a logistic regression analysis. As I said before, even in logistic regression, you have the beta coefficient. Even in logistic regression.
Sir, can you explain again, sir, regarding this last thing?
Okay, so I will show you a table of logistic regression. Okay, in logistic regression also, you have the beta coefficient. Okay, in logistic regression also, you have the beta coefficient. But in logistic regression, we don't use the beta coefficient. We use only the odds ratio. Yes, we use only the odds ratio and say it is a adjusted odds ratio. Okay, so this is the logistic regression table. Okay, if you see over here, if the odds ratio is greater than 1, if the odds ratio is greater than 1, you see positive beta value. If the odds ratio is less than 1, you have a negative beta value. Can you see over here? If the odds ratio is greater than 1, if the odds ratio is greater than 1, you have a positive beta value. If it is less than 1, you have a negative beta value. The same thing is happening. The same thing is happening over here. The same thing is happening over here. Here, if you see the beta coefficient negative, that is equivalent to odds ratio going below 1. Actually, what, for example, male gender, you have thought that male gender is the risk. Okay, but since the beta coefficient has become negative, now the risk has shifted to the females because you are interpreting that male sex when compared with females have a 1.5 unit decrease, which is understood as females have 1.5 unit increase when compared to males. You understand? Male
Yes,
sex
sir.
when compared with females, males will have a 1.5 decrease, which is understood that females have a 1.5 increase. Yes. So the risk has switched. So which shows that male gender has become protective. Yes. Male gender has become protective. Same thing only happens in odds ratio because everyone confused beta coefficient with odds ratio. In logistic, we don't use beta coefficient because we have the odds ratio. In linear regression, we have no choice, but we have to use the beta coefficient. So you have to understand how to interpret the beta coefficient. Okay, we have to understand how to interpret the beta coefficient. So in linear regression, 1 unit change in the independent variable, how much change it produces in the dependent variable. So that is what is being explained in this table. Okay, so negative, again, like in odds ratio, it has become protective. Positive, like in odds ratio, it has increased odds of the unit change increases in the dependent variable. Clear? So this is the linear regression. This is the linear regression. So in linear regression, you can have the independent variables as either categorical or quantitative. Okay, quantitative na innum easy ah irukum. Okay, for example, you are having something like height and weight. Okay, height and weight or something, some income and life satisfaction score. As the income increases, satisfaction increases. If beta coefficient is, for example, 1.5, if beta coefficient is 1.5, you can say that 1 unit increase in the income will increase the life satisfaction score by 1.5 units. If the beta coefficient is 1.5, I am saying. Okay, if 1 unit is increase in the income, will increase the life satisfaction score by 1.5. Okay, the problem occurs when the independent variables are categorical. So that is when you have to understand the risk and no risk. Okay, switch in the independent variable category, how much beta coefficient increase or decrease. Beta coefficient is similar to odds ratio. In odds ratio, you see less than 1, greater than 1. In here, you see minus or plus in beta coefficient. Okay, and below each and every regression table, we have to make sure you write all these things. Nagal karke R square, how much over here, and p-value, and all variables with p less than in bivariate analysis were included for logistic regression analysis. So as I said before, you cannot simply take all the variables inside the regression analysis. You have to first do the bivariate analysis, whatever is applicable, chi-square or t-test or ANOVA or whatever you have, and find what all are found to be significant and take all those into the regression analysis. Okay. So it may be a little confusing for you. The nicotine data sheet which I have provided for you, use that. Okay, use that. So if you have over here, if you want to play with linear logistic regression, use this. Okay, use this. It has only 2 categories over here. Okay, and run the regression with the independent variables and see. And if you want to do a multinomial regression, use this one. This has dependent variable has more than 2 categories. No, sir, I want to do linear regression. Then you use the raw score over here, which is the quantitative dependent variable, and run the regression and see for linear regression. And try to understand all the output which we see over here. All the output which we see over here. All the coefficients and the 95% CI, all the odds ratio. Okay. So this is regarding the regression, linear regression, binary logistic, and multinomial logistic. So I think you will be having lots of doubts.
Sir, like in any publication, if you are doing a regression models, then we have to specify the enter model and everything. So that we have to mention we have done by SPSS, but looking at they might ask for a certification also, no? Of the SPSS.
Certification means
that you have purchased the SPSS software and everywhere, like.
See, it is, I don't know how to answer this question, but ideally they will not ask the license of SPSS and all. Okay, license of SPSS and all. So it is like safe. I mean, till now, no journal has asked me like, show me your license of SPSS. So you can put like, you have analyzed data using SPSS, and mostly they won't ask you anything like a license or something like that. Okay. So any doubts you have in regression?
Sir, one doubt, sir. For multiple linear regression, both the predictor independent variable and outcome dependent variable in quantitative nature la da irukanuma illa qualitative ipo neenga discuss pannappo independent variable and education occupations எல்லாம் அதெல்லாம் qualitative தானே சார் அது
quantitative இருக்கலாமா qualitative இருக்கலாம் பட் ஆனா அதுக்கு இன்டர்பிரேஷன் நல்லா பண்ணணும் ஏன்னா இப்ப ரிகர்ஷன்ல நீங்க எடுத்துட்டு போகும்போது when you take the qualitative variables into a linear regression it will reject the variables which don't have a numeric scale. For example, if you see here this occupation, education, and marital status and all, it is numeric. Okay, it is numeric. If I have string over here, it will not accept string variables into the linear regression.
Okay, sir. Thank you, sir.
Okay, so you can take the categorical variables inside and also the continuous variables inside. The only thing is continuous variables, it will be easy for you to interpret. 1 unit change in the continuous variable has produced this beta score change in the dependent variable. But in case of categorical variable, you have to understand, as I said before, one switch in the category of the independent variable increases or decreases how much beta score of the dependent variable. Okay, this alone will become difficult for you, but when you practice again and again, you can easily interpret. Likely, what they expect you from the analysis is, this R square value and how much these all variables together, how much they are good in predicting the outcome variable. That is what they expect. They don't expect you to write the interpretation of beta coefficient. They don't expect you to write the interpretation of adjusted odds ratio and all that. Okay, see.
Thank you, sir.
Clear?
Sir, this adjusted odds ratio and exponential beta both are same, no, sir?
Same.
But beta coefficient is different.
Yes, beta coefficient is different, but as I said, beta coefficient and adjusted odds ratio are closely related. If you see, when the adjusted odds ratio is greater than 1, beta coefficient will be positive. When the adjusted odds ratio is less than 1, beta coefficient will be negative. Okay, but if you have odds ratio, it is enough to have the odds ratio. But in linear regression, since I want to explain to you people regarding the relationship between odds ratio and beta coefficient, I showed an article which contains both of them. Both are entirely different, but they go hand in hand. Okay, if odds ratio is protective, then the beta coefficient will be negative. If odds ratio is showing us risk factor, then beta coefficient is going to be positive. Okay.
Okay, sir. Thanks.
Yeah.
Sir,
now we will-
multiple logistic regression and multinomial logistic regression are one and the same. Does the name differs?
This again a terminology which is highly confused by many people. Okay, so what you need to understand is binomial and multinomial. Okay, binomial and multinomial. Binomial dependent variable has 2 categories. Multinomial dependent variable has more than 2 categories. That's all, finished. And univariate regression, follow me closely. Univariate regression and multiple regression. Okay, some journals I have come across, they have used the term something called univariate regression. Univariate regression is nothing but I am removing education and marital status and seeing the association between a dependent variable and a independent variable. So this contains only one variable. This contains only one variable and you have a p-value over here. Okay, this is in some journals, they say this as univariate linear regression. Okay, if I take more than one variable inside, for example, education and occupation inside, and I have 3 variables inside, then it is called multiple regression. You understand? If you take only one variable inside the regression model, it is univariate regression analysis. And if you take, because if you see for this occupation, the beta value, if you see here, it is minus 0.96. For the same occupation, you see the beta coefficient has become positive. That is how the interaction happens. Okay, this is only occupation presenting inside the regression model. Here, occupation along with education and marital status. That is the beauty of regression model. Okay, if I had 2 more variables inside the model, again the beta value will change, the significance will change. Here you see, it is statistically significant, when I have occupation alone, But when I bring two more variables inside, the significance in the occupation variable is gone. You understand? So this is univariate regression. This is multiple regression. Don't confuse this with multinomial regression. Okay. Multinomial
Sir,
regression.
after this,
Yeah, tell me, sir.
sir, that after the test, the relevant test which we use, we can directly come to the regression, like correlation should we can skip that part.
No. Correlation and regression, they are not synonyms, or they are not something which has to be like taken together. Correlation is completely different from regression. So that is why I
Okay.
wanted to finish regression before going into correlation. Okay,
Okay,
because
sir.
even in our textbook and even wherever we go, we say like correlation and regression. They are not, they both are completely different concepts. Okay, so whatever
Okay.
bivariate analysis you do, chi-square t-test or unpaired t-test, ANOVA, Mann-Whitney, or whatever you do, among the 10 variables, how many are significant? 4 variables are significant. Take those 4 variables, decide the dependent variable, quantitative or qualitative. Qualitative, logistic. Qualitative, how many categories? 2 categories, binomial logistic. More than 2 categories, multinomial logistic. That's all, over. If it is a quantitative variable, dependent variable is quantitative, go for linear regression analysis. Okay, and find the R square, goodness of it, and adjusted odds ratio in case of logistic. You see the R square value, you see the p value significance, and the beta value in case of linear regression. Okay, clear?
Yes, sir. Yes. Thanks.
Okay. Now we will go for the correlation. So correlation, this partial and distance. So someone was asking about the partial distances and canonical correlation and all. So these are all just a little advanced things. Partial is like, even among the continuous variables, you have a ranked order inside the values. You go for partial correlation. Okay. And distances, as I said before, the Mahanabi's distance and all these things. So these are all little advanced topics. Whenever we plan to organize something on advanced SPSS statistical test, we will concentrate on partial distance and canonical correlation and all. Okay, now, as of now, we deal with only the bivariate analysis. Okay, so correlate, bivariate. Okay, here we have the Fagerstrom scale over here, which is the continuous variable, and you have the age over here, which is again a continuous variable. Okay, which is again a continuous variable. So my hypothesis is, as age increases, the smoking score increases. Okay, listen carefully. As age increases, the smoking score increases. So this is my hypothesis. So which is what I'm going to test. So Pearson correlation, two-tailed, okay, and everything is done. So if you see over here, you have the p-value, again, statistically significant, and I have the positive correlation. So positive correlation means as age increases, the score increases. As age decreases, the score decreases. So that is positive correlation. I have seen people confusing, like, sir, as score decreases, as age decreases, the score decreases. It is a negative correlation, sir. No. Negative correlation is, as age increases, the score decreases. As age decreases, the score increases. That is the negative correlation. Okay, so as per my hypothesis, it is showing us positive correlation, and the correlation coefficient is 0.501. Okay, so as Kevin sir was teaching you, 0.3 to 0.5 like low correlation, and 0.5 to 0.7 moderate, and above 0.7 is high correlation. So here, which we have something like a moderate correlation based on the correlation coefficient. Okay, so again, non-linear distribution, if you see, in case of correlation, you go for Spearman's correlation. Okay, sir was teaching you about, right, monotonic in distribution in scatter plot. So not normally distributed, many outliers are there. If you find like that in your dependent variable, which is the Fagerstrom score, many outliers are there and it is non-linearly distributed, then you go for Spearman correlation, which is almost going to give you the same value only, but sometimes you may lose the significance depending on how many outliers you have. Depending on how many outliers you have. If you have many outliers, Pearson correlation is highly influenced by outliers. So if you have outliers, whatever significance you get, it is overestimated. So if you don't want to have the influence of the outliers, and if the data is not normally distributed and non-linear distribution of data, then you go in for non-parametric correlation, which is the Spearman correlation, which is denoted by this. Okay, I think I was not done to the correlation. Okay, so correlation again, like we have for parametric and non-parametric, for normally and non-normally distributed, you have the Pearson and Spearman. Pearson, minimal outlier or no outlier, normally distributed, Pearson. Not normally distributed, many outliers, you go for the Spearman correlation. Okay, that's all correlation. Correlation, the rule is both has to be quantitative variables. Both has to be quantitative variables, that's all. The ideal example which they give in textbook is height and weight. As height increases, weight increases. As height decreases, weight decreases. This is what hypothesis is. So you plot some 100 participants height, 100 participants weight, take into the correlation and see what is the correlation coefficient. So the simple example which they give in all the textbook is this only. That's it with the correlation. Okay, so now initially we saw about
if
the
the value, the significance value more than 0.05, and there is no correlation.
No, can't get you.
Yes, sir, the significance value, if the more than 0.0
has to be less than 0. Less than 0.05.
No, if it is more than, then it's we can say like that.
No. The p-value, if you see here, it is less than 0.05. 0.00 is the p-value. You understand here? 0.000 is the p. It is highly significant. One thing you have to look at the correlation. Okay, you confuse that 0.502 is the p-value. No. 0.000 is the p-value. Okay. Okay, so any doubts you have? So I will just, tell me, someone was asking something.
We have an advanced.
Can't understand, man. Can you come again?
Will we have an advanced expression version after this basic version?
Your voice
Will
is
we have an
muffled.
advanced expression workshop after this basic workshop?
Yeah, we are in the planning stage. We will let you know. So in advance, you can see. In advance, we can see about this block regression, hierarchical regression. See, in linear regression, you have something called blocks over here. Block 1, block 2. Okay, and you have the Z-squared and you have the SRE SID in the y-axis, x-axis, and you produce the normal probability plot. And here you can have the save as the residual, see, Cook's distance and all these things. Okay, this confidence interval and all these things. What are the standardized residual, unstandardized? All these are part of the regression analysis, but they are seldom reported. If you want your article to have a higher chance of publication in big journals, if you report all of these together, the Cook's distance, Mahanabli's distance, and all these together, it will have a higher chance of publication. So likewise in logistic regression also, you have many advanced components over here. Okay, as I said before, you have the interaction models. You have here again, you have the Cook's influence. You have the unstandardized and standardized residuals, and also you have the case-wise the correlation of estimates, classification plots. So all these will come under a little advanced thing in which regression alone will take around 1 to 1.5 hours, maybe even 2 hours for us to explain from bootstrapping to each and everything. Okay, and we in ANOVA we have the post-hoc analysis. Okay, and we have the MANOVA, we have the ANCOVA. So many things are there which we have not touched today. We have just touched the basic bivariate analysis, what all the tests we have, and the significant variables which are found in the bivariate analysis, where we have to take. We have to take to the linear regression, binomial or multinomial. And I just showed you the basics of regression analysis. Okay, so rest of the things we can see in the subsequent advanced classes if we are planning. Okay, that we will let you know after speaking with the TATCOM board members and the academic team. Okay.
Sir, sir, in the repeated measures ANOVA and pair t-test, some articles they also adjust for the time, so they take the time in a crossover study. So will that be covered?
Will adjust the time.
Like repeated measures of pair t-test within a 2 weeks or 3 weeks later, they adjust for the time also.
Okay, time. So see, this time component and all this and all will come under different types of analysis. Okay, so there's something called GLM. Okay, as you see
Okay,
before,
sir.
I'm showing you. You have the GLM, you have the univariate, you have the multivariate. Okay, so in multivariate component, we have something called dependent variable, we have something called fixed factors, we have the covariates. So in this, you have to adjust and put all the variables. Okay, I think it will take a long time for me to show. I'm just showing you this. GLM models, as you said, this time component and this hazard ratio and all these things, no, hazard ratio also, in cohort study also, time component will be there. So all these components now we will analyze using this GLM models. So again, GLM models, again, it is a generalized linear models are there, and we have the general linear model, and here you have the repeated measures over here. And again, in repeated measures, you have to, as you said, you can add the time component and whatever variable you have, you can add this and you can define and then run the analysis. Okay. Again, that will take a long time for us to explain. Maybe we will cover those separately in some other
Excuse me, sir.
session.
Yeah, thank you.
Yes.
Excuse me, sir. Sir, I wanted to ask about the
Yeah.
p-value cutoff point for selecting variables in logistic regression.
Okay. This is again a topic of debate. Okay. For example, p-value cutoff, we usually keep p less than 0.05. Okay. P less than 0.05. But there's a chance. Okay. For example, depression and obesity. Okay. Depression and obesity. We all know that there's a statistical significant association between obesity and depression. Yes, we all know. But unfortunately, in your analysis, the p-value comes as 0.065. 0.065. So you are forced to omit obesity into the regression model. So that you feel that scientifically should not happen. Okay. So what you can do is, you can take the p-value less than 0.10. Okay. Variables which were found to be at a statistical significance level of 0.10 are taken into the regression model. Again, you are only taking into the regression model. In the regression model, you cannot relax the p-value. You understand?
Yes, yes.
You are taking obesity inside the regression model because you feel that obesity will be one of the good predictors of depression in the regression model. You are taking it inside. For that, you are relaxing the p-value. But in the regression, again, the regression p-value you cannot adjust. That has to be at the 95% CI. Okay, this is actually a very good question because I have seen journals which have kept the p-value as 0.20. In bivariate analysis, all variables which are found to be statistically significant at 0.20 are taken into the regression model. So this also I have seen in many journals. Okay. So this is another very good one.
Thank you, sir.
Yes, any other doubts? Shall we wrap the things up?
Sir, in between in afternoon session, like somebody highlighted the topic of the keyword effect size. So, sir, the effect size we have to take in the sampling method when it is clusters and or this stratified random, or if else we don't require now.
No. This effect size and all will come under cluster sampling.
Okay. Then, sir, it's in stratified.
Actually, maybe.
Yes, sir. Anand sir, can I come in, sir?
Yeah, Vijay.
Yes, sir. So to answer your doubt, sir, so whenever we go with non-simple random sampling methods, we tend to use this effect size. Okay, so in order to nullify the sampling variations and the sampling errors, we tend to add this effect size in order to make sure that we increase our sample size. So ultimately, whenever we increase our sample size, the sampling variation and this errors and all will be less. That is the ultimate goal of using this effect size. We can use it in sampling methods which are non-simple random. Let it be stratified, let it be clustering. So even in stratified, we will be having that proportionate to size, disproportionate to size, like those sampling methods and all. We tend to use this effect size just to increase our sample size so that the sampling variation and errors are less.
Okay. Thank you.
I was searching for one document that actually in cluster sampling, no, you have a formula. Okay, you have a formula in which there will be a cluster correlation coefficient and the effect size. Okay, maybe if I find the PDF, I will send you in the WhatsApp group so that you will have an idea what role the effect size plays in sample size calculation. Because like as Vijay sir pointed out, he has given a beautiful, simple explanation. But if you want to dive into the details, you can look over the PDF, which I will share in a few minutes.
Sir, are you talking about the intra-class correlation coefficient, the design effect?
Yes.
No, sir. You had mentioned that you're looking for some documents, so I just want to know if you're looking for this.
Looking for, yeah, that document only.
The design
Okay.
effect.
That document
That
only.
only.
Yeah. I mean, I am searching for the document. I had it in my laptop somewhere. I am not able to find it. I will, in some after the session, I will just send it in the WhatsApp. Okay. So anything else? I think Dr. Vijay, we can wrap things, I think.
Yes, sir. Sir, is there any kind of assignment that we are going to give for the participants, sir?
The thing is, we have already shared the data sheets with you. They can work on different combinations of analysis and they can come out and you can contact Dr. Vijay Karthikeyan that if you have any doubts or clarifications and you want some review class. Dr. Vijay sir, are we planning for review class?
Yes, sir. If the participants are willing and if they are having some doubts in the analysis based upon the data sheet which we are sharing, we can have it, sir.
Okay. So if you want a review class, the participants can put up in the group and Dr. Vijay sir will decide on the date and time and let you know.
So before that, all of you just go through those data sets and do the analysis so that any doubt if you have in those analysis based upon these data sets and all, we can have a discussion regarding that. Okay, so you just play through those data sets. Okay, so you just try different combinations, different sets, and you can even recode the data set and you can just try it. Okay, so transforming the continuous into categorical, and you can just try various tests and as well as the various analysis parts and all. Okay, so if there are no further queries, I hope we can just wind up today's workshop, and I would like to thank all the participants for staying back till 7:30 around. Okay. So because we planned it for only up to 4 p.m., but each of the session got extended. And I would like to thank both the resource persons of this evening session for just staying with us for this workshop. Okay, so if there are any queries, the participants can post it in the WhatsApp group, and we will be sharing the post test link. Kindly all the participants fill the post test link also. Okay. So until next time, this is Dr. Vijay Karthikeyan on behalf of TATCOM Academic and Research Wing. We are signing for today. Thank you all for joining. Thank you, Anand sir.
Thank you, Dr. Vijay. Thank you.